Good evening, everybody. Once again, we're back with another weather system here. And we've got the tropical air rolling in. I had to just shut off the air conditioner and the dehumidifier. We've got dew points up near 70 where we're at. Moisture is coming up northward. Hello, everybody, and welcome to the Meteorology Lab. This is Tim Vasquez, and we'll cover weather across the U.S. over the next 20 minutes or so. And just taking a quick look at chat. Alexi says, one confirmed tornado by Whitney, Texas, around 6:30. I don't really remember where Whitney is. I'll take a quick look at that. Go to the old Google Maps, and I've been looking at weather across the entire U.S., and that's one problem with doing this weathercast, is I've got to cover so much territory that it's hard to cover what's going on. Okay, yeah, there's Whitney. It's near Hillsboro, and we did have an area of kind of weak, what looked like weak thunderstorms. They were kind of shifting northward just before sunset, so I guess we squeaked one little tornado out of there. Let's take a look at what's going on, and I'll go ahead and just pull up the radar for Fort Worth. Since we're in the warm sector, we'll look at that for sure. So yeah, okay. Boy, I've been kind of oblivious to what's going on. Yeah, that looks like a little rotating storm right there near Midlothian coming into the southeast part of Fort Worth. And Whitney was down here, so that looks like it is moving up to Arlington. Now, I'm not sure if Arlington is under any threat, but we'll take a look at that as we get towards the end of the weathercast. And looks like an MCS all set up here west of the DFW area. That's probably the cold front coming in. We'll check out the surface map and see what's going on here. First, however, let's go back to this. This is showing the warm air. This is the temperature anomaly map, showing a lot of warm air from the Carolinas all the way back to Texas here. So we can kind of use that to find the front. So looking something like that. I'm surprised to see Oklahoma, the east part, above normal. So I guess we've had a little bit of erosion of that cold air mass through there. Highs today across the U.S. look like this. Temperatures have come up a bit in Oklahoma and Kansas, so we've had some air mass modification going on. The warm ground conducting heat to the boundary layer, but temperatures hanging on a little bit below freezing in western Kansas right there. So that's the main icing threat area for this evening. Temperatures in Texas itself above, as far as highs, they crept up above freezing there today. Upper level chart looking like this. Let's look at the large scale pattern, and we can see pretty zonal flow through here from the Pacific. So we got one jet kind of set up like that. Actually, I think that would go all the way up to Alaska, kind of like that. Then we have our southern stream affecting Texas and the southeast. So we've really broken down that blocking pattern, and we're bringing these troughs in, and the current one right through there approaching the mid-band area. 250 millibar chart, we haven't really looked at this much, but this definitely pinpoints where the front is. And we're looking at something like that, maybe even a little bit further north. And this can be important with thunderstorm patterns like this, because if you have strong winds aloft, you will have long-lived storms. This separates the updraft from the downdraft. And we've got 60-knot winds there over Fort Worth, so that's helping a bit there for the convective activity in that area. Looking at the thickness chart, we'll just check this out real quick. You can see a lot of banding there in Texas. So this is suggesting a warm front from southern Arkansas through Dallas, and then back towards the Big Bend area, and then down into Mexico, like that. Probably another little weak boundary through here. We'll probably check that out on the surface chart. And then another boundary coming here through the Carolinas, probably joining up with that front there. And this is probably a good time to look at the surface data. Here's the current data. Let me get this centered here. And we can definitely see a cyclonic circulation there in the Dallas-Fort Worth area. So let me paint that out. So right there, looks like some sort of low, maybe west, somewhere west of Fort Worth, kind of in this area around Mineral Wells and around Granbury. And bringing the front down, that would go back to the Big Bend, kind of like that, probably just behind that MCS. And then we would bring that eastward to about Greenville and back to El Dorado, Arkansas. So that's it. That's the front coming through North Texas. And as we saw, MCS in place, kind of like that, right along the cold front edge. It looks like a little bit of a convergence here in Oklahoma. It's probably a bit of an occlusion right there. Temperatures above freezing pretty much everywhere. So probably just kind of like a very marginal ice threat through northwest Oklahoma. The main ice threat area is in Kansas. And all of the main part of Oklahoma above freezing there. So it looks like our main threat of wintry weather is going to shift up into Kansas and Missouri tonight. But for Texas, we are going to watch that thunderstorm area coming through. And let's look at soundings real quick. Dallas-Fort Worth sounding just 2 hours ago. Let me get that centered right there. Showing a weak bit of cold air near the surface associated with these easterly winds right there. Got just a little bit of turning in the lower levels, but the winds are kind of strong, so that's probably given us just a little tiny bit of curvature there. I am going to try to pull up the Fort Worth photograph here in just a minute. But as far as instability, lifting this parcel here, very narrow bit of instability there, so that would probably be capes around 250 to 500. Not really severe weather like May type stuff, but that's enough to give us, a few showers and storms there. Norman, Oklahoma, north of the warm frontal boundary, there you can see the frontal inversion, and that's topping out right here. And you're probably finding it kind of hard to tell just how deep this cold air is. But each of these lines here, you can probably kind of estimate that as about 1,500 feet. That's not true up here. This is strictly near the ground. So 1,500 feet per line. A good cutoff for freezing rain, between freezing rain and sleet. Freezing rain, and sleet, is about 600 feet. So that's going to be about half of a line like that. Now this is all above freezing here, so this is all going to be rain. But up at Dodge City, they're below freezing. This is probably deeper than half a line. This is probably one full line. So we're looking at about 1,500 feet of sub-freezing air. That's going to favor probably sleet. On the other hand, if the layer is kind of warm, and this is kind of a little bit warm, then the falling precipitation will probably stay liquid up to a certain extent. So if this column is warmer, it will tolerate it being a little deeper for freezing rain there. So yeah, Dodge City right there is on the edge of the freezing rain threat there. Take a quick look at vorticity here on the 500 millibar chart. There we go. That's going to be this evening's pattern. Right, yeah, that's 16th at 0Z. Trough through Midland out to San Antonio. So I guess we're going to have a trough approaching this area over the next 6 hours, and that's going to expand the precip coverage probably towards midnight. It does look like most of this energy goes up into western Oklahoma and stays west of I-35, though. And this is probably associated with the polar front jet, probably a jet streak coming through here. right there. So this area here is in the left front quadrant of that. So that's probably what's going on right there. So very strong winds over the Dallas area at the jet stream level. Most of the dynamics to the left of that jet max. And then for 12Z dawn, that vorticity lobe will shift up into the Wichita to Enid area. And then things should start improving a little bit in Texas. You can see that ridge building in here tomorrow evening. And then we're going to deal with this towards Monday and Tuesday. Here's the SPC mesoscale analysis, and you can see a pretty good MCS line. A couple strong cells here around the Hondo, Texas area to Uvalde, out through the hill country. And this part of the line here, from east of Wichita Falls down to Stephenville, pretty weak, but we do have that one rogue cell out ahead of it, and that's what we're watching coming up into the Arlington area. Okay, let's see. I was going to take a quick look at radar here. Let me bring up the radar. I was going to show you a little bit of dual pole stuff. And I've got GR level 3 here. There's the Dodge City radar right there. So we can see some precipitation out in the area, kind of light in this area, and then a little bit heavier down here. Or is it heavier? Let me see if I can show you something. Let me see if I was going to bring up a cross-section in GR level 2, but I think that's going to kill the connection. Maybe there's a different way I can show this. Yeah, you see how as you go higher and higher, this is 0.5 degrees. You see that line, that area of heavier showers right here. As we go up higher to 1.5, it's even closer. And as we go up to 2.5, it's even closer. So any idea what that is? That is the melting level. The best reflector of radar energy is wet snow, or wet hail. Wet hail or wet snow. So basically wet ice particles. And that's what we're seeing here. This area, as you get up in this area, let me draw this out, away from the radar. In this area, this is far from the radar, and since the radar beam is conical, this is up at higher elevations. This is up at 10 to 15,000 feet. Whereas the stuff in here is very close to the ground. So what you're seeing here is increasing height as you go away from the radar. So as a result, eventually you're going to hit a level where the freezing level is, and below that some mixed precipitation falling out of the cloud. And that's what we have right here. And GR level 2 and GR level 3 paints this white band here to show you where that melting level is. So it falls within that white band that you see here. Then we have this gray area. This is where the top of the beam starts entering the melting level area, and this is where the bottom of the beam kind of exits that area. But this here represents the center of the beam. So that's what's going on there. And there's another product here. This is differential reflectivity, or ZDR. And this is the ratio of vertically polarized energy coming back to the radar versus horizontal. In other words, you're observing the energy coming back from the radar in a vertical plane like this versus a horizontal plane. And that's important because if you have rain falling out of a cloud, very large droplets, they're going to take on kind of like an oblate shape like this. Let me move this out of the way. Yeah, so it's going to be kind of like that, kind of like a pancake shape. And as you imagine, if you're looking at this through a slit like this, you direct your radar energy through this slit, it's going to reflect a whole lot of horizontally polarized energy. But if you're looking at that same droplet with a vertically polarized slit, it's going to reflect very little energy back. So you can take that ratio between the two and get an idea of the shape of the particles. And that's what we see here. So values that are, let me see if I can get that scale in here. Yeah, you see that scale right there? Values that are very high, these are oblate shapes, kind of like this, pancake shapes. When you're near zero, those are neutral shapes, so it's more spherical. And when you have values that are negative, you've got a more vertical orientation. And that's what you're going to get with ice crystals. I'm sorry, I didn't draw that right. There, shaped like that. So that's what you have with negative ZDR values. That's what you'll get with snowflakes and ice crystals. And that's the reason we kind of paint that with a gray color. So what we see here is slightly higher values close to the melting level, and then they're actually lower as we come closer to the center of the radar. Now, I'm not too sure why that is, but I suspect that maybe we've got more spherical particles, so maybe we've got smaller raindrops in here, whereas here we've got larger melted raindrops. Then as we go even higher, we start picking up a little bit more of the ice crystals and snow. Now, another product we have is the hydrometeorological classification algorithm, the HCA. And as you can see off to the left, this gives us a whole bunch of different categories, all the way from heavy rain and rain, blowing dust, graupel, hail, all the way up to unknown particles. Then we've got some other stuff here like ice and biological, that would be birds. And it uses kind of like a fuzzy logic algorithm to kind of figure out where all the different areas around the radar fall into here. And it's basically using ZDR, reflectivity, correlation coefficient, stuff like that. So what it's showing us is that very close to the radar, very low to the ground, it's going with rain. Now, of course, it doesn't know that the rain is freezing on stuff, but it's assuming that everything in here is pretty much liquid. As we go up higher into the melting level, it's going with more of a mixed phase. It's got wet snow, it's got some ice mixed in, and it picks up blowing dust. Obviously, it's not that, but it's picking up signatures that resemble that. And then as we go higher up into the sub-freezing level of the cloud, we've got dry snow. That's this category right here. So this isn't what's happening at the ground. This is what's happening along the radar beam. So right here at Dodge City, we're very close to the ground. Up here, we're at, let's see, 5,000 feet. In here, we're at 10,000 feet up to 18,000 feet. So there you go. There's a quick radar refresher. And I'm going to get rid of that, and we're going to go over to Fort Worth and see what's going on there. So let me select that. We go into GR level 3, and we pick out our radar. This is pretty neat because we got all the TDWRs. This is a program written by Mike Gibson. Some of you might have heard of him. He's been at a few conferences like the ChaserCon, and he writes the software here. So let's go with the Fort Worth radar. Looks like we got is that a tornado warning out? Yep. Let's check this out. Tornado warning for southeast Tarrant County. This is a radar-indicated tornado warning. They're going with, let's see here, severe thunderstorm capable of tornado south of Mansfield near Highway 287. Okay. So we got some weather going on right there. And we're looking at the HCA, the Hydrometeorological Classification Algorithm. And as you can see, it's going mostly with rain around there. And then in this core here where the storm is, which we'll look at in a minute, it's got this area of red, which is hail, and then this area of green, which is heavy rain. So it's actually doing a pretty decent job picking apart what's going on in the storm. And you can actually make out the MCS right here. So that's pretty neat. It's picking up a couple areas of rotation. Looks like a little bit of a tornadic rotation possible along the leading edge. And let's go ahead and flip over to the base reflectivity. And we've got our storm there with a pretty good hook. Man, it seems like Arlington can't catch a break there. It seems like Arlington is located right here. So I'm glad we're not dealing with that here. I'm going to have to pull up GR level 2 since this is something going on here. Now, before I do that, we'll take a quick look at base velocity. And you can see some pretty good rotation in there. And the first thing you want to think about is where the radar site is. So that's right there. Because everything that you look at on the velocity products is tied into the orientation of that to the radar site. Okay, so what we got here, we've got outbound velocity. Red is always outbound, positive. Let me draw that out. And then we got this area of inbound. So we're painting out this very large area of rotation right here. And embedded in that, I don't really see anything that looks like a tornado right now. The diameter of this rotation, probably about 2 to 3 miles. So that's a pretty good meso right there. Got 52 knots out and 35 in. So I'm going to set that right in the center of that rotation. One thing that's good also is to go up and look at the next higher tilt because you might see some stuff going on there. So this is 0.9. And we can see the rotation tightening up a little bit right in there. Okay, I'm going to switch over to GR level 2, so let's do that since we've got a little bit of action going on here. We're going to load up GR2 Analyst. Okay, let me get this all set up here. Now, you probably need to be patient with me. This is going to suck down one of the level 2 files. If the connection starts getting flaky, just hang on there. This is only going to happen for a minute. Okay, so here we go. I'm going to start pulling in the data. And while it does that, let me look at the chat here and say hello to Sue and Ron there in Southern California, Alexi in Texas, who alerted me to this tornado here. Tom J, hello, and Kevin and Sue. Kevin checking in there, noting the tornado warning storm. Lexi mentioning warnings for Laughlin Air Force Base. That would be in the Del Rio area. Sarah and Sue and Michael. Ancient Astronaut. Heavy cell heading for Canyon Lake. Michael Burrell mentions Georgia. They've had a high of 77, setting a new record. The last high was 75 in 1937. And Alexi mentions tornado warnings for Kerr and Johnson County. And hello, Fred. I'll try to get to that hemispheric when I get a chance. Jeff checking in there, and the skinny checking in there also. Okay, our products are up. Come down to that cell here. I've got the shape files on. Let me turn that off. There we go. And we can see that one cell coming up into the Arlington area. This is going to be 0220. That's going to be 5 minutes ago. And I'm hearing a bit of thunder out there. And we're located a little bit southeast of there. No problems there. Okay, there's our cell there in southeast Tarrant County. I'm going to look at the base velocity here. This is actually pretty close to the radar. When it's this close, I like to go up to 0.9 instead of 0.5, because that gets me a little bit out of the ground clutter. So 0.9 is going to give us this. And the rotation right now looks to be fairly large. So we're looking mostly at a meso here. Let me set up the storm mode of velocity, and I'm going to set up the storm vectors. I'm not sure what motion we're looking at. I'm going to go probably 220 at 15. Let me balance that out just a little bit. Okay, let's see what magnitudes we're looking at. The outbounds, this is the RFD area right here. This is the area that's kind of along the hook. And it's showing that we've got about 45 knots outbound right there. Then the inbounds are out here ahead of it. That's showing 60 in. So we've got about 100 knots of shear on this storm, 100 knots of large-scale meso shear here. And basically we've got a meso kind of set up like this. I'm going to set this in the center of the meso, which is going to be about right there. Let me switch over to the base. Oh, we got a new frame in here. Let me go back to that previous shot there. Okay. This is where the center of the meso was about 6 or 7 minutes ago. It was kind of set up like that. And you can see this area here, this is the rain-free base. This is where that's going to be. And then back in here, this is the rear flank downdraft. So we got the storm rotating, coming around through here along the hook. And over here, we've got the inflow coming into the storm like that. Then another product we can look at if we're suspecting a tornado on the ground is spectrum width. And to me, spectrum width is very underutilized. A lot of times when we have a debris cloud starting up, you'll see a very strong core. And we don't have that right now. What we see here, this is a lot of the inflow air coming into the storm. And let's advance this to the latest frame and see what's going on. Looks like the inflow is kind of filled in a little bit. Storm relative velocity tightening up a little bit here. And we've got, let's see, about 52 out, about 47 in. That's going to be about 100 knots of rotation still. And we're looking at a diameter on that rotation, about 2.5 miles. So that's that's pretty classic mesoscale range right there, mesocyclone range right there. So the center of the circulation right there. And boom, there it is. Now, one thing that we like to do is also look higher up into the storm to look at the structure, the large-scale structure. So I'm going to go up to higher tilts here. I'm going to go up to 1.3. You can still kind of make out that inflow area here. It's kind of turning into an updraft as we go up higher. And you can see, the echo is jumping around here a little bit because the times are a little bit unsynced. See, we got a slightly older frame here, but you can see the updraft area right there. And this is up at about 4,000 feet. Wow, we are pretty close to the radar here. And as we go higher, it looks like that core kind of fills in. Then we get to the top of the storm here at about 30,000 feet. So we're dropping back down. Yeah, see that right there? That's the beware as it's seen horizontally. This is an area of lower reflectivity values. This is basically the updraft. You can see it's right over that dot that I've plotted here. Right in the center of the rotation there. So that's where all the action is. And as we go lower, that opens up into a rain-free base area. Now we've got a new frame here. So anyway, that's what's going on with the Arlington storm. I'll probably come back to that in a bit. And we've still got radar indicated rotation on that. And before I let that go, for now, I'm going to look at the spectrum width. And still looks like no surprises there. So where's that heading? Let me just take a quick look at that. That's going probably about 030, just about northeast, kind of like that. So that should take it into the Grand Prairie area and into Irving over the next 20 minutes or so. Okay, elsewhere down the line, just pretty weak cells. Nothing that concerns me too much. Okay, so let me bounce over to the chat, and Felix there. Whoa, 100 knots, about 115 miles an hour. Looked it up. All right. Let's take a look at the forecast over the next few days. Then we'll go back to the radar in just a second here. Here's the GFS. There's tonight's weather. We know we got the warm front somewhat like that, and the cold front down here. Then for tomorrow's webcast, system is going to move northeast. Main icing area is going to be north of Omaha, north of Des Moines, in this area here. And by evening, it's going to be set up like that. Kind of a cold front stalling in East Texas, stalling in the Little Rock area. And then warm front coming through Indiana and Chicago. Or maybe coming directly through there, maybe something like that. But in any case, lots of warm air. A lot of liquid precipitation through here. And very weak cold air advection on the back side. For, let's see, Tuesday's webcast. That system moves through the Great Lakes area and into the Lake Ontario area. System is centered about at Toronto. So there's the front. It's kind of quasi-stationary through southeast Texas. And then the warm front through New England like that. Looks like they've got a better shot of cold air coming in from the Canadian Maritimes, so they're getting a little bit of icing and sleet problems in New Hampshire and Vermont and Connecticut, and upstate New York, north of looks like north of Albany, Dutchess County. Then for Wednesday, let's see, pretty quiet across the U.S. We're just kind of under the influence of this plateau high pressure in the Four Corners area, the receding high pressure in the southeast U.S., and we've got a westerly component, so that means a warm-up for the central U.S., and then we've got a new Pacific system coming in California and Oregon. So you see the thickness lines, they're kind of bunched up right there. That's our new system coming into California there. And that'll be coming onshore, and the main reflection of this will be in the upper levels at this point as it comes inland. So for Thursday, we can barely see it in this area. You can see the thickness troughing in here. So we probably got the front something like that. Pretty hard to find. Shower activity in southeast Texas right there. Looks like the moisture is still coming up from the Gulf in that area. Then for Friday, low pressure emerging in Texas, kind of warm westerly downslope winds. And looks like another Pacific system coming in through Southern California there on Saturday. And there it comes through Arizona and New Mexico during the day on Saturday and makes it into Texas around Sunday here. Now, one thing you can see here is the thickness lines. They're pretty far south. They're kind of bunched up down along the Texas coast. So we're probably looking at the front kind of like that. Well to the south, and that leads up to an occlusion over the Dallas area. So it looks like in the wake of this front, we'll see a lot of cold air coming southward next weekend, and we'll get a cool down here about then. Yeah, look at that cold air coming on down. System coming through the southeast U.S. on Monday the 23rd. And here comes another system out of California into Texas by Wednesday the 25th. So we'll be watching for another winter storm in the Central Plains about then, about midweek. Then Friday and Saturday we get to the end of the run right there. Okay, so that's the forecast, and we'll take a look back at what's going on there in Arlington and Grand Prairie with that system here. Got a new tornado warning on that for Dallas County. Still radar indicated here. And you can see the cell looks kind of HP-ish here. This is the rear flank downdraft area here, kind of filled in with a lot of precip. And looking at the outflow on the storm, probably something like that. So it's kind of like a mini front. In that low pressure area, that's basically the mesocyclone within that storm. Okay, let's take a look at the shear profiles on that. Again, we're going up to 0.9 to get a better picture. And one of the things that I really like, not really like seeing, but one of the strong indicator of tornado development is when I see kind of like a large wall of very strong inflow, kind of concentrated in this area. I'm not seeing that right now, but that's one of the indicators I would look at for an imminent tornado, because that often kind of like firms up, and then we see a very strong tightening of the circulation. Don't quite have that right now, still kind of a broad circulation. Diameter on that looks to be about 2.5 miles still, so not a whole lot of change. Got 52 knots out and about, 36 out and 34 in, so it looks like it's weakened a little bit here. The circulation center located about right there. And then we can match that against the reflectivity data. Is that correct? 0 to 233? Yeah, that's correct. Okay. Yeah, so this is the center of the circulation right there. And then we've got the rain-free base right there. So if you're chasing the storm, this is about where you'd want to be, somewhere in this area here, maybe up here. So basically in southwest Grand Prairie right there. Then looking at the higher tilts, kind of follow that inflow area right there. Then it looks like we start picking out a little bit of the beware. I guess, I don't know, it could be that one or that one. I'm not too sure. Let me see here. Yeah, I think that is probably the beware right there. Then we go up higher in the storm, and we hit the top of the cloud, and you can see it's fairly sheared because the top is right here, and that's quite a ways downstream from the main storm here. So it's being sheared downstream like that, leaning over by about 5 or 6 miles. In this echo right here, this is up at about 34,000 feet. Okay, Alexi says, church and 5 homes damaged in the Whitney storm that happened at 6:30. How low in elevation does the jet stream get in relation to the ground level? It's normally about 4 or 5 miles off the ground, which is about 30,000 feet. It can get as low as about 20 to 15,000 in cold air regimes, especially around the Arctic front. That would be about 3 miles or so, 15,000 feet. Haven't really seen the core of it much lower than that. Yeah, beware, echo-free vault. Let's see if we can paint that out using the cross-section. Okay, you can see I'm kind of stretching out a cross-section line from west to east, and that brings up this here. And the, let's see here. I don't use these cross-section products too much. I tend to use stacking of the horizontal frames. That seems to work better for me. But sometimes you can pick out a few features on here. I can't really find the beware very well in this cross-section. You kind of have to hit it just right to be able to find it. And we're actually looking for that to be kind of in this area here. And I'm just not finding it. It really tends to be, for some reason, it's easier to pick it out just by going up to the higher frames like this. And then you can kind of follow the rain-free area and watch it close up as you go higher. So probably there. I don't know. So it's either that one or that one. It's kind of hard to tell. It's pretty messy at this time right now. Now, one thing you can kind of see on this storm is that the reflectivity gradients have been diminishing a little bit. When I first looked at the storm, you can see the reflectivity gradients were a lot tighter, like along this leading edge right here, and maybe even in here. We've seen that kind of loosen up a little bit. So now it looks a little bit mushier here. It's probably starting to disorganize just a little bit, and as I mentioned, it looks like the velocities on this circulation area are coming down. So I think probably what I'm going to do is take one last look at the cell, and then we'll stop the weathercast. And then if anything unusual happens, I'll keep an eye on it. If we have any unusual regeneration of some tornado activity, we'll come back on the air here. So just checking out the velocity real quick, and then we'll kind of close it up. So a little bit, can't really tell what's going on here. It looks like the cell is going through some sort of transition. Yeah, we had it like this on the previous frame. Okay, yeah, the circulation is kind of like this right here. So we've got got this area 55 knots outbound. Then it's kind of weak through here. I'm probably going to wait till the next frame comes in just to make sure that this isn't something spinning up. You can hear some more thunder out there. Okay, so what I can do real quick is put on the roads. I've got this GIS menu. I've got a shapefile loaded up. And you can see that puts on the street level pattern. So the cell is pretty much coming up to the I-30 area here, just east of Six Flags, coming up through northwestern Grand Prairie. And if you want to download your own shapefiles for GR Level 2 and GR Level 3, I don't know if any of you are familiar with it, but if you go to Google and put in shapefiles and GR Level X, there's this page here, W. Scott Lincoln. He's got all these street level road data sets that you can load into the program. So you basically click on your site and download it and install it, and you'll be good to go there. Okay, don't have the, let's see, do we have the latest data yet? No, still waiting on that. Okay, keep the jet stream high for us. Yeah, definitely we'll do that. Bounded weak echo region, yeah. And a little bit of trivia, when the bounded weak echo region does not form a concavity at the top, when it's kind of open, we just call that a weak echo region. It's called a WER, a WER. Otherwise, if it does form a closed concavity, that's a BWER. Thunder here coming in where Lexi is, somewhere in central Texas. Probably take a quick look at that. Zoom that out. You can see that MCS coming into the Fort Worth area, coming in through Cleburne, and Meridian, Gatesville, all the way down to Lampasas. And we do expect this line to kind of stall out overnight along and just east of I-35. It'll probably kind of be in this area by dawn. And then it will make a very slow progression tomorrow and tomorrow evening into southeast Texas. So there's our MCS right there, and you can see this warm air advection wing. This is where there's a little bit of lift along north of the warm front, kind of like that. Cold front kind of like this. And a lot of the lift is focused on the warm front, not so much on the cold front. So because of that, these storms are mostly driven by isentropic lift. They're kind of like overrunning storms, kind of like embedded, more stratiform showers and storms here. Okay, we're downloading some data. Let me know if you're getting any glitches on the feed, because these files are about 2 megs or so each. And I've only got 6 megabits per second here. Okay, we've got the 0240 frame. Let me see, 0233, 0240. Yeah, we're expecting the new frame to come in any second. 0233, 0240, so the next one should be coming in at 0247. That should be 2 minutes ago. Once we look at that, we'll be done here. So we can check the spectrum width here and look at a few products. Nothing interesting on the spectrum width right now. Echo tops. This looks at the highest incidence of a certain reflectivity level. and it's picking up about 31,000 feet on these storms. VIL, that's a good indicator of your total precipitation in the vertical. The problem is in sheared events like this where the storms are leaning over, this does not work so well because it kind of spreads out the scatterers downstream. Then we've got ZDR here showing nothing too interesting. And then we've got this interesting product called KDP. I'm not going to get too much into how this works, but it uses phase changes to give you kind of like a simulated reflectivity picture. And what's interesting about this is it is immune to attenuation by rain. So if you're penetrating a lot of rain showers like in tropical storms and it degrades the reflectivity, you can use this KDP to see exactly what's going on. So this is showing our storm right here in Arlington and Grand Prairie. What's matched up to the base reflectivity? It's pretty close. And you notice some parts of the storm, they kind of stand out better than the other parts of the storm. So that's probably more associated with heavy rain and hail. Okay, still waiting on the next update. I think this is the first time we've gone 50 minutes on the webcast. So let's see here. A little bit of chat, just some talking back and forth. We've got our next update coming here in 20 seconds. If that doesn't take, I'm just going to go ahead and sign out here. Still sitting on the 0240 data. Probably what we're going to do when we get into spring, when we get a more active pattern and a lot of nighttime thunderstorm outbreaks, we're probably going to do 2 to 3 hour live webcasts and talk about the radar and severe weather. And we'll kind of like take breaks for about 10 minutes and just show radar in the background with some music and then come back on and talk about it. We did a little bit of that back in October. We came on about 2 or 3 in the morning and talked about a severe thunderstorm event in East Texas. So we'll be doing some more of that this spring. Okay, downloading. Okay, I don't think I have any data, so I'm just going to let that go. I don't see any big problems here. Anyway, I appreciate you watching, and we'll just sign this off and roll the old music, and I hope you all have a good evening. We'll be back later tonight if anything gets super interesting. Other than that, I appreciate you watching, and we've been doing Weather Lab since July, mid-July, and we did a little bit last summer too, so you can go back through the archives for that. Anyway, we'll see you tomorrow night. Thanks.